Right, the next part of this chapter that we're going to talk about is exchange reactions, and that's really what we're doing with the double exchange, where you've got two compounds and they exchange partners. Okay, another name for it, is ionic, double replacement, double displacement, and they also have one called metathesis. It's an exchange reaction, and it just comes from the word to transpose. Okay, it appears in the ions, and again, if you look here, we've got magnesium nitrate, and over here, the magnesium goes with a hydroxide and the sodium goes with the nitrate. Okay, so they're switching. And again, if we go back to what we did before with, is this really a reaction? Well, these two are aqueous, dissolved in water. But look at this one, forms a precipitate. So if you look, hydroxides, magnesium hydroxide forms a precipitate, so we know this reaction occurs. Okay? So if you're going to do one of these reactions, okay, the first thing you have to do, and I did part of that before, is use the chemical formulas of the reactants to figure out what ions you have. Okay, so you're going to break them down into ions and then use the formula of the products, the cations from one reaction and the anions from another. Remember, positive goes with negative. Don't put two positives together and two negatives together. That ain't going to happen. In other words, the metals go first, the nonmetals go second. Okay, and then you're going to use your charges to write, your proper subscripts. You can't just say, if it's calcium hydroxide, it's not CaOH. It's Ca and then OH in parentheses 2. So you still got to use your charges to write the proper formulas. And then check your solubility to make sure that, if one of the products is insoluble, then you got a reaction. That's a precipitate, and balance your equation. Okay, so I was showing you that on the little video, and I'll do another one after this to show you how to do these reactions. If we're going to write an equation, again, for a molecular equation, so first thing we do is we complete the ionic equation. Make sure, you change your reactants so in your products they exchange partners. Then you write a net ionic, and what a net ionic is you break it down into ions. Okay, so if it's calcium, you would write it as Ca plus 2. Okay, and again, I'll show you how to do those. Okay, so the molecular equation, it lists the reactants and products without indicating the ionic nature of the compound. In other words, this is what you'd start with. So if I started with these two guys, I'd finish my equation and I'd make sure I had one that was a precipitate, because if there's not a precipitate, you're done. The reaction doesn't occur. So here I have lead 2 nitrate. So I put lead with chlorine here, and again, I'm going to have a 2 by the chlorine because this is 2. How do I know that? I don't even have to look it up. All I have to do is go here. Is nitrate's got a 2 by it, so lead must be 2. And then potassium chloride. Okay, now the potassium is going to go with the nitrate. And again, they're both 1. So I wrote out my equation and I balanced this. This is my molecular equation. Okay, this states everything that's in there. Now what I need to do is break it down into ions. Okay, when you do your complete ionic equation, you guys, what you do is you break it down into its ions. Okay, so here you go. Now instead of writing lead nitrate, I have lead with a plus 2. And you don't have to write in the AQs, you guys. Okay, then I'd write 2 nitrate because it was NO3 with a 2 on it, plus 2 potassium plus 2 iodide. So really all I did was break it down into ions. Okay, then over here, this guy got to keep together because it forms a precipitate. So lead iodide, I do not split up into its ions because it doesn't form ions. It forms a precipitate. So I keep those two guys together. And then my potassium and my nitrate, this is NO3. I know I'm in the way, I'm sorry. But this is 2NO3. Okay, so now what I did was I broke it down into all of its ions. And if it forms a precipitate, you guys, it doesn't break down into ions. So that's why this guy stays together. Okay, this more accurately reflects what's going on. Because now what I'm going to do is I'm going to get rid of what they call spectator ions, and that's probably the next slide. But spectator ions are the same on both sides. So here I have 2NO3. Well, I got 2NO3 here, so these would go. I'd get rid of those. And 2 potassium and 2 potassium, so I'd cross those out. Okay, those would be spectator ions. Okay, and again, I did that. Once I get rid of my spectator ions, then this is what really occurs in that reaction, is lead 2 and 2 iodine combined to form lead 2 iodide, because this is the precipitate. All the rest of them, because they're the same on both sides, they're not really involved in the reaction. Okay, so you cross out anything that does not change from, if they're the same on both sides, you cross them out. And again, those are called spectator ions. Okay, they're there, they're just watching. Okay, so the potassium and the nitrate, we cross them out on both sides, and this would be our net ionic equation. Okay, the remaining ions are the reactants that form the product. Okay, this is an insoluble salt. This is what happens. This is why we know that reaction occurred, because we formed this precipitate. And again, you got to keep that solubility chart that I told you to run off, because that's where all the rules are. I don't expect you to memorize those, guys. I don't know how to memorize those rules. But anyway, you get, this is what they call the net ionic. So we have the molecular, where you have everything that's involved and it's balanced. And make sure you have a precipitate, because if you don't have a precipitate, you're done. Okay, then you break it down into ions, and then your net ionic equation is what's really involved. So that's crossing out your spectator ones. Okay, so how to write a net ionic equation. Again, first thing you do is you write a balanced molecular equation for the reaction. Okay, you're going to get the two reactants, make your two products, make sure their formulas are written right, and balance your equation. Okay, rewrite the equation to show the ions. Again, break them down. If you have calcium chloride, it's calcium plus 2, chlorine minus 1. Plus, if it was magnesium bromide, magnesium plus 2, bromine 2 Br. Okay, so you write them down, you break them down. Then double check your products. Make sure one of them is a precipitate. If there isn't a precipitate there, you're done. You cannot go any farther, because all you have is ions. There's no reaction. Okay, so here it says only strong electrolytes dissolve in aqueous solution. So that's why you write them in your ionic form. Okay, and then identify and cancel the spectator ions. If they're the same on both sides, you just cross them out. Okay, they're watching. Okay, they're spectators. All right, they're not really involved in the reaction. So you cross those out. So you get your total ionic equation, and then your net is when you get rid of the spectators. So really what you do with a net ionic is you have the two reactants that form the precipitate, and that's what you end up with. Okay, so here's one with calcium oxide. Okay, now this is this is a synthesis reaction, calcium oxide producing that. Okay, so this is reduction. Wait a minute. Yeah, okay, we're going to do that next. So right now we're going to work with these net ionic equations. I'll have a video on them, and then the end of this chapter talks about oxidation reduction. I don't want to start on that today. We'll just do these to start out with, and then we'll hit the oxidation reduction. So we're done with today's lecture, or this part of the lecture, and then I'll show you how to do net ionic equations.